Okay. Okay, so, well, that's actually the linked list. Okay, so that's not what I wanted to show. Okay, so first of all, I'm gonna start by reviewing just the two topics for the quiz, another Lambda expression example and and an example with the predicate. And then I'm gonna talk about linked lists, but I'm not talking about anything new. I'm not talking about anything that you're gonna be tested on. So the linked list, I'm just doing more for completeness. I did, if we were in the classroom, I'd probably give some assignments on the stuff we were doing tonight. But it's just easier for me to, in that kind of environment to test on this. Okay, so let's just look at this student class right here. So here's what my examples are. And some of it I have to admit I did do, okay, which is good. I did do in, maybe we'll just start with the predicate. Okay, so I did do some of this in the previous class, like the one that the previous lecture at 2:55. Okay, so let's talk about the predicate. So the one thing we remember, so let's just remind ourselves, the predicate is just an interface. Here's an example we saw the other day. And can you see, you can see Eclipse, I assume, because
yes.
Okay, so the predicate, okay, so it's actually it's an interface. It's actually defined in, okay, it's kind of highlighted there. You have to import a java.util.function. There's a folder, java.util.function. It has all these interfaces. They have exactly one method, right? Those are the functional interfaces. The interfaces have one method that we're forced to override. And so the predicate interface has one method called test and returns true or false. And so whatever's in that generic variable, that's the parameter type to test. And test just returns, as long as you're returning true or false, the compiler is happy, but we want to return something meaningful. So in that example from last time, test returns true if the integer is a multiple of 4. So now here, let's go to the student class now this is the student class from homework 3. And actually I put a main method in it just so, which isn't that unusual, because if we're, let's say we want to test some feature in the student class, maybe we would just write the main method right in the student class. I just like having the main methods, for an application, having the main method separately, but just to test features right in the class itself, it's not unusual to have the main method there. And I did it here just so I wouldn't have to go back and forth between files a lot. Okay, so we have this student class and we have an array of students. Okay, and so what I do is, so let's just look at this student predicate that class that we defined, or I defined here. Okay, so the student, so because that's one of the things you're going to need to do is just write a predicate, or you're going to have to implement the predicate interface. So I wrote one called student predicate. So the whole class, so here's a class that implements a predicate and the generic type is student. And I think what it's doing here, let me remind myself. I did so we're going to look at the average grades. The average grade of the student, let's say, because remember, that's one of the methods in the student class is get average grade. So, okay, so the test method is passed to student, and we're just all we do look at is get average grade less than 80, true or false. And that's all it is. So I'm actually giving kind of simple. The test class, the test method itself is kind of simple. So let's go back to student. And okay, so now we have our student class, we have an array of students. So now so starting on line 110, we have that enhanced for loop, and we're just going to loop through that students one array. And if sp.test, so sp is that predicate, is a student predicate object, because student predicates implements predicate. We know it's guaranteed to have a test class that returns true or false. And if you want to know what test does, you actually, you can look, there's either documentation or you actually look at the code. So in our case, sp.test returns true if the average grade of the student is less than 80. So let's just see if that actually works. It's really not a lot of code. And so, in this case, there's 2 students whose average grade is less than 80. And then if we wanted to change that, hello, student predicate class right here. let's say we wanted to look at the ones that were, 80 and above. All we'd have to do is go like this. And let's just run this, let's just run student again. Now we'll get all the other students. Well, it's only 4 students. So let's see here. Yes, in this case, yes. So in this case, we have 2 students whose average is greater than 85. I mean, greater than 80. Okay, so that's all I wanted to say about predicate. I just wanted to review a predicate. So the whole thing was, so here's my, it's a student predicate class right here that I wanted, it's just a review of what we did last time. So any question on that, Jose?
No, not right now.
Okay, so then the harder thing is, let's go to, I don't know, harder, but maybe a little more sophisticated. Okay, so we don't actually have to implement, we actually don't need, for these functional interfaces, the interfaces with exactly one method. Remember, we don't need to actually create a class. There's something called the Lambda expression. And so let's do a Lambda expression for comparator. And so let's just look at a review of comparator just for a second. So here's like string comparator. So remember, if you're going to implement comparator, there's going to be a compare method. And so in this case, the comparator, the generic variable is string. So whatever the generic variable is, the input to the compare method, there's 2 parameters that are identical to the input to the generic type. So if we're going to write a comparator of type string, then the compare method inputs 2 strings. And remember, so the compare method has 2 parameters, and the first parameter is greater than the second parameter if the compare method returns positive. And this first parameter is less than the second parameter if the compare method returns negative. But you don't actually have to write a whole class just for, because all we really can, we're writing this whole class just to get that compare method. So remember, what the Lambda expression does is essentially it defines the compare method. We just write code for the compare method, and we pass that, let's say, to the sort method. So actually, I've already written this. Okay, so let's see right here. Okay, so I'm going to actually just comment this out right here, just so you don't see that output. And so here I already wrote this, so I'll just uncomment all this. So remember, there's a method called arrays.sort. You have to import java.util.arrays, and the sort method actually will sort the arrays. Remember, there's 2 versions of it. There's when you put in one parameter, it sorts the input parameter has all the objects in that array have to implement comparable, and then you sort based on the rule in the comparable. Because remember, sorting, you're comparing, like for insertion sort or selection sort, you look and you find the smallest one and you put that in position 0. And the next iteration, you find the next smallest one and put it in position 1. So you have to be able to compare objects to sort. So when there's just one parameter, we're using the rule in the comparable interface. And it's defined in the compare to method. Now here, there's 2 parameters, right, or 2 arguments. So the first one's an array of type object, right? The array doesn't, the objects don't have to implement comparable. And then the second parameter is a comparator object. And remember, the comparator object, remember, has that compare method that allows us to compare objects. We just saw that example in string comparator. So instead of like in that first example where we, actually, write a class and then create an object based on that class, we'll just write the compare method as the argument. And that's what the Lambda expression does. Remember, the Lambda expression, we know we have in a Lambda expression, we have that dash arrow. Okay, so on the left of the dash arrow, those are the parameters to the compare method. And we don't have to say, well, we know students 1 is an array of students. So implicitly, student S1 and S2 are student objects. So we don't have to write that. And then what's on the right side of that, arrow is just what's returned by the compare method. Okay, So the compare method is going to take two student objects and just subtract their highest grade. And so in this case, if S1 has a higher grade than S2, then S1 is greater than S2. So the student with the higher grade is the greater object. So the first time we sort, so for the first time, like on line 117, we'll sort in, the sort method always sorts from smallest to largest. So when we actually print out, so we sort it, it actually changes the ordering of the array. So if you need the original ordering of the array, you need to save a copy. But when we're done with arrays.sort the first time on line 117, the student objects will be sorted from the student with the lowest highest grade to the student with the highest grade. It's hard to say. And then if you look there on 122, see the great thing about Lambda expressions, we don't have to keep creating new files every time. We don't have to write a new class every time we want to change the rule and compare to. So we just write a new Lambda expression on line 122, and we just switch the role of S2 and S1. So in this case, so the input parameters are S1 and S2. S1 is the one on the left, and it's positive, right? So if S1, if the highest grade of student S1 is less than the highest grade of student S2, we get a positive value, right? Because when you subtract two numbers, if the highest grade of S1 is, because we're subtracting S1 from S2, so it'll be positive when S1 is smaller than, the highest grade of S1 is smaller than the highest grade of S2. So in this case, the student with the least highest or the lowest highest grade is actually the bigger student object. So when we print it out, the student with like if you look here, which is the student with the highest grade? So okay, so I think it's student. I think it's the Gita L, the second, the one that's at position 1. So L, the student whose first name is Ellie or L, this person would actually be the smallest student object because that has the highest grade. And Gillian has they all have high grades. So their highest grade is high. So Gillian's highest grade is 90. It's the smallest. So that would be so in the second case, that would be the biggest student object. So when we print them out, we should see them reverse. So let's try this. Yeah, so the first time Gillian it's going in ascending order by highest grade, because the first one is actually the smallest object. So the lower the highest grade, the smaller the object. And it's just reversed for the second one. The higher the highest grade, the smaller the object. So yeah, so the second case, it just printed out in reverse order. All right. So we've done that a few times, I guess, but that's my review of Lambda expressions. So you see, there's really not a lot. So this quiz, I think I gave you way more time than you need if you're prepared. If you're not prepared, and then you're stuck. There's really very little code to write. But do you have any questions, Jose?
No.
Okay, so that's the review. That's my great review. Okay, so now let's talk about linked lists. And I want to talk about this iterator. Okay, so I want to talk about so here's my linked list class, the linked list class that we wrote for, let's say in homework 4. If you use the for each loop on it, like if you tried to, it wouldn't work because we don't have there's still some mechanism that we're missing. So I'm going to show you how to write it. Mine actually already has it. And you know what? I forgot to put this online for you. Here, let me. Let's see here. Let's see here. Hold on. I'm going to just stop sharing for a second, and I'm going to upload this file for you, in case you want to look at it while. So just give me a second here. And I meant to do that, and I forgot. Okay, so it's just taking me 1 second. So I'm going to put this in lecture 11. Couple of files here. Okay, so give me 1 second here. Oh, sorry, I'm recording this. Okay, sorry, recording people. You could just kind of fast forward a little bit. Or make a phone call while I'm doing this. Okay, so oh, honestly. Okay, so going to link list. I'm going to upload. Okay, I'm just going to upload this file right here. Okay, so just give me 1 second here. Okay, so you should see that, yeah, the iterator. So if you go to lecture 11 linked list, under lectures, I put this iterator file, and then let me just put the code up there as well. This linked list code, all under lecture 11 here. So I created a new folder called code, and just take me 1 second here. Okay, so where is that? Okay, right here. And then, oops, there we go. Okay, so yeah, let's go into, so let me see. So I'm back here. Sorry for that delay. Yeah, so under lecture 11, you should see this iterator folder, this iterator file, and also a folder called linked list. Okay, so let me go back to sharing here. Okay, so this is what we're, okay, so I want to look at this iterators. Okay, so this is really kind of, I think a really good topic if you're, in case you go into like a 4-year school and knowing how these iterators work. Okay, so let's see. So we learned about this for each loop at the beginning of the year. Now, how does it, it's a little bit like magic, so there's actually code behind it. It really is just an ordinary, for as far as linked list and array list, and even for arrays, the for each loop is really, it kind of gets converted to an ordinary for loop, the kind of for loop we learned about in Math 130, but we're just kind of hiding the details. We type in the for each loop, and then the compiler just generates bytecode that's equivalent to the kind of the Math 130 for loop. Okay, so first of all, there's actually this interface called, okay, well, first of all, if you want to use the for each loop, you have to implement a, like we can use the for each loop on linked list, array list. There's actually a collection class called stack, and these all come with the Java development kit. And all these classes implement this interface called iterable. So if you want to use the for each loop, your collection class has to implement iterable. It's java.util.iterable. And the iterable interface defines one non-default method, and it's called iterator. And iterator itself is an interface. We have to know about these two interfaces, iterable and iterator. Okay, so the linked list class, so our linked list class is going to implement iterable, which means it has to have this method called iterator. And iterator has to return an object whose underlying class implements iterator. So let's look at iterator. Okay, so the iterator has a method called hasNext. I'm not sure I'm crazy about these. These method names are a little bit confusing. So next isn't actually, next, I should probably rephrase that. What next does, it does two things. It actually returns the item in the current node object, and then it advances the pointer to the next element in the collection. Okay, and so hasNext actually returns true if the current node object is not null. or basically it's, yeah, so if we can actually go, pointer as assigned pointer, if we're allowed to go pointer as assigned pointer dot next without generating an exception. Okay, so then I think when you see the code, it might make a little bit more sense. And that's all we need are those two methods there. Okay, so to implement iterable, yes, so your linked list class has to look like this now. Linked list implements iterable, and those e's, so the generic type is the same in each one. And then you have to have this method called iterator, okay, that returns an iterator object. Okay, so my code would look something like this. Return new linked list iterator. Now, it turns out linked list iterator is going to be an inner class. So remember, it's a class inside of a class. Like the node class is an inner class. It's actually defined right in the linked list class because our user doesn't need to know about the details of a node and doesn't need to know about linked list iterator. So it's just this private class, and this linked list iterator will actually be the class that implements iterator. Okay, so and so there's your private class. And so what we do is we start pointer at the head. So there's an instance variable called pointer. We initialize it to head. And you see there that method called hasNext. So it returns true if the current pointer is not null. And then the next method, so it saves what's in the current item, right, where we are in the linked list, and then it advances the linked list to the next node. And then returns the item from the previous node. So it kind of does two things. It's going to the next node in the linked list, but returns the item in the previous node. And that's it. Okay, so and then we'll look at the code in a second. Okay, so let's say we have this enhanced for loop. Let's say we have a linked list of strings. You know, we're printing out the contents of all the strings in the linked list. So what the Java development or the compiler is actually seeing is this, right? So the list, so if list is a linked list object that implements iterable, it has an iterator method, right? It has this iterator method. And it returns an iterator object, right? And so it returns an iterator object. An iterator itself is so we know that K is guaranteed because so iterator it's an interface, right? That has methods called hasNext and next. So we know that K has, so we can actually invoke the hasNext method and the next method on K. Okay, so we get this, so we initialize K to be this iterator object, and then we check the Boolean expression. That's that middle term, right? hasNext, meaning is the, remember we initialize pointer to null, to head, right? So is the current pointer, and hasNext, this is, so we start pointer at null, and hasNext, this says, it basically returns true if pointer is not null. So is the current pointer non-null? If that's true, return the item, print the item that's in the current node, and then move the pointer to the next node. Okay, so basically, it's just moving this. So we start the pointer at the head. So in every iteration, we go, oh, is this null? And if the answer is no, okay, so we're gonna advance. So we're gonna save what's in the current. Let's say there's a Z here. So let's save the current item. Okay, and then move the pointer to the PTR to the next node, and then print out what was there before. And when PTR is null, hasNext returns false, and we stop. So we're just iterating. We're just going from node to node. And there's really very little code in all of this. And now it kind of makes the enhanced loop makes more sense. It's not kind of like, well, how does this work? So so let's just look at the code right here. And I might have actually changed the iterator in my last. And then we're going to look at the remove method too. So let me just try this. So it's all the way at the bottom here. Okay, so well, first of all, what do we have here? We had yeah, so we have to import the iterator. And then where is, okay, hello. It's all the way at the bottom here. Yeah, there's our, yeah, because since we're implementing iterator, right? We're implementing iterator. So we have to have that iterable, we have to have a method called iterator. Right, so we have the method called iterator there on line 216, and it returns a linked list. The name of the object is, the name of the class is not important, but what's important is that inner class implements iterator. And yeah, and then we have to have that generic variable e, the same as the one of the, that we pass to the linked list class itself. And actually, I did it in another example. We'll go back to this, but let's do it like I have in the notes. So we start at the head, and we'll advance to the next node. So now I have this linked list test here. And so yeah, let me just, so let's first check that the, okay, that was the opposite of what I wanted to do, okay. Okay, so let's see if the enhanced for loop works. And now can we now use the enhanced for loop on our own link, the one we wrote for homework 4. So, okay, so first we add cat, and then dog will be in front of cat, and then zebra will be last. So it's dog, cat, zebra. Okay, so now we're going to have that enhanced for loop. So in this case, the head would actually be dog, and so the PTR, so the PTR variable would start at the node that contains dog. And yeah, and it works. All right. Let's go back here. This is what I was saying before. We don't necessarily need to use, I mean, of course you'd want to use it because that's kind of elegant, and you don't need to know about most people don't know about iterator or iterable or anything like this. But let's say we want to actually write a regular kind of for loop that we learned in Math 130. And now, see, this is what I'm saying. We could actually write this instead of, this would be our replacement to the enhanced for loop. Because this is exactly what the enhanced for loop is doing. It initializes the, instead of like a counter, like int I, what we have is an iterator object. And the first thing we do is we initialize it. List is our linked list class. So we take the result of list.iterator and assign it to K. And then we check is K, so is the current pointer equal, referring to a node that's non-null? If that's true, yeah, we will print out, we'll advance to the next node, but print out the node, what was in the node before. And this should work. But to use this, you actually have to import iterator. It should be the exact same result. All right, and it is. But what I was saying, what I did before my last class, I go, there's no reason why an iterator has to, like for a linked list. So all the enhanced for loop has to do is visit every node. I don't think there's any requirement that it starts at the head and goes to the last. I think even for arrays, I'm not sure if there's any documentation that says when you use the enhanced for loop on an array, it has to start at 0. That always does. So instead of starting the pointer at head, we can start it at last. Instead of going pointer.next, because we have this, because we have a doubly linked list. Now, if it was just a singly linked list where all we had was a next, we couldn't do this. Okay, but now we should go backwards. So again, so our linked list is dog, cat, zebra. So now it should print out zebra, cat, dog. All right. And it does, because we changed the next method all because we changed the next method in the linked list class. All right. So that's all you need to, and then on Monday, what I'm going to do is talk about how to do this for, I'm going to just review the code in the array list classes so you can see it. And we'll write an iterator for the link. I'll just show you a couple of methods in the the array. Basically, I want to show how we can add, how we can make, how the array list is this, looks like this infinite array. So I'll show the add method in array list and also how to do an iterator for array list. Though not, you won't be tested on that, but I just want everyone to see that who might be interested. So one more thing, any questions on this before I talk about how to do the remove? Okay, so now remove, the famous remove. So we learned how to, so I showed you how to remove from the beginning. There's remove first and there's remove last. Let's say we want to remove from the middle. So we know how to remove the head and we know how to remove at the last. Let's say we want to remove in the middle. So let's say we want to remove a node that's not the first one or the last one. And so I used to actually would test students if they knew this code. I'm not sure why I tormented them with that. So it starts at line 22. And so let's look at the code and then maybe I'll draw some pictures to verify that, you know, I always think linked lists and pictures go together really well. Okay, so remove I. So in this case, what does I refer to? Head is node 0. And then last would be node size -1. So first of all, let's check that our index is not out of range. So if I is negative, of course, you know, we throw an exception. And if I is greater than or equal to size, we throw an exception because you can't so if there's 10 nodes in the linked list, we can't remove node 10. It doesn't exist. The nodes are numbered 0 through 9, just like an array. Okay, and the other thing the remove method is going to do, it's going to return the item stored in the removed node. So we don't lose it forever in case we want to use it. Okay, so if I is 0, so there's two special cases. First of all, let's check to see, is I 0, we're removing the head. And then it's just like the code for remove first. You know, we save temp as head.item. And so let's see here. So okay, yeah, so yeah, so if I is 0 and temp will just make temp equal head. Oh, first of all, if size is 0, we're guaranteed that their size is at least 1, right? Because if size was 0, you would throw an exception. I guess that's what I was trying to stress. What is it? I feel like I'm trying to say something. What is it? Okay, so if size is 0, then you're guaranteed. And if I is 0 or above, you're gonna get an exception, right? Because anything, all non-negative numbers, any number, if size is 0, any number you put in there will throw an exception. Okay, so we're guaranteed that size is at least 1 if we don't get an exception. And so if I is 0 and you're at the save what's in the head and temp, and if the size is 1, okay, so a head will be signed, just like we've seen before, head equals last equals null, or assigned last is just make head and last null. Okay, if size is greater than 1, we're just going to remove the head node. Okay, and then so head is head.next, we just advance the head 1, and head.previous is null. We've seen that before. Okay, so now let's say size isn't 1. Let's say I is size -1. And so we're at the last node. And again, we've seen that it's like remove last. So that's like make temp equal last.item. And just remove the pointer in 1. So last is last.previous. And then last.next is null. Okay, so that we've seen before. That's just the code for remove first and remove last. Okay, let's go to the else part. That's the interesting part. So you start the pointer at the head, and we're going to traverse. We're going to make pointer refer to the node that we want to remove. Okay, so you see in that loop there, we're going to iterate. We're going to iterate I number of times. So let's say I is 1. Let's say I is 1. You're going to guarantee to iterate 1 time, and so that pointer would stop at node 1. And if I was 2, you'd iterate twice, and the pointer would stop at node 2. So forth. If I is 3, you iterate 3 times and stop at node 3. So, you're always going to stop. Pointer will, by the time you're done with that loop, pointer will refer to the node that's going to be removed. And so you just save the item in temp. And it's that, and I'll show you, I'm going to just draw pictures for 46 and 47. We have to link up the nodes. So if you're going to remove this node, you have to link up the one that comes before and the one that comes after. So I'm going to try to draw that in a minute. And then of course, the last, you want to make sure you reduce the size by 1. Now, one thing I just want to warn you about before I try to do my great illustration is that I've seen students, there's a possible, just be careful of side effects. So look at all this, I could, like if I 0, instead of basically I'm repeating all the code for remove first. Now I could just, why don't I just call remove first? You have to be careful, we could just be careful if you do that, because what does the remove first method do? The last thing remove first does is size minus minus. It reduces the size by 1. So you just want to make sure you don't go size minus size. You want to make sure you don't go size minus minus 2 times. Right. So if you're removing the head, you don't want to reduce the size by 2. You just want to remove it by 1. So you just have to be careful with it. That's a logical error I've seen a lot. So so if your remove method calls remove first, remove last, just make sure size minus minus is only applied for when you're removing from the middle. Okay, so now let me just open up this. Let me see if I can draw on this here. So let's see here. Go to the end here. Oh, so let's say here, let's say we have a bunch of nodes here. And let's say this is the one, let's say it's node 2 I want to eliminate. So we start there, remember, so we're going to iterate. So your pointer starts there and then we traverse 2 times. So we end up, so your pointer ends at, right, so this is 0, 1, 2, 3, and 4. So let's just assume we want to eliminate 2. So that for loop will iterate twice. So we'll end up there and the pointer will refer to node 2. And then what we're going to do, remember, is we're going to go, was it pointer dot previous. See, this is what we want to do. We want one to point to what's currently 3, and the 3's previous points to 1. So we're going to go pointer dot previous. And so 1 is actually dot next. So that's what we saw in the code. So let me just. So this is pointer. So this would be pointer dot previous. And then this would be, the one after pointer would be pointer dot next. Right, so what we're saying is that pointer dot previous dot next, what would come after pointer dot previous? We're saying instead of being what's now at node 2, make it node 3. So we just, all it does, we have to make sure and reset these next and previous properties. And then the other one, the same thing true for pointer dot next dot previous. It has to be pointer, the one before pointer. And so that's all we're doing. We skip right over node 2. So now to that node, what was it, that pointer, that node that was, used to be node 2, it's not in the list anymore. So node 3 is now actually node 2. So, and then the garbage collector, if no one actually refers to that node, if no variable is actually referring to this node, it actually just goes away. Pretty wild stuff. So so the one thing I didn't do in here, so I don't have the add method. So if anyone, if you're interested, you or anyone who's listening, if you want to maybe try practicing with, I'm sure everyone's super busy. Well, I know you're very busy, but at some point maybe in your life, you might just want to try to write the adding in the middle. I didn't put that in here, so. Okay, and you're not, so once again, you're not tested on any of this linked list stuff. I just want you to, I just wanted to, I always teach this, if you were in the classroom, I definitely would be going over this, so. Any questions, Jose?
No, thanks.
I'm just going to stop sharing. I'm going to stop the recording. So